Okay, so for this question, we're going to do the sum, which means we're going to add. We're going to do the product. Oh, sorry, difference. I skipped the difference. We're going to do the difference, which means we're going to subtract. And then the product, which means we're going to multiply these two complex numbers. So when we add them, I like to color code. For example, I'm going to do the real, and I guess this is like pink or something, real. For my imaginary, I'm going to use orange. And so when I add, I'm going to add my real, 3 plus 4. And then I'm going to add my imaginary, I plus minus 2i, which is a minus 1i. So my answer, or my complex answer, I guess, it's complex, is 7 minus 1i, or just minus I, where the real is 7. Imaginary is minus 1. And then we do the same thing for the difference. For the difference, I'm going to do my real minus real, that's -1. And then my imaginary minus the imaginary. 2 negatives make a positive, so that's 3i. So my complex -1 plus 3i, where real is -1, imaginary is 3. The product is where it gets a little bit heavier. I like to do the quadratic, or not the quadratic, the X puzzle, just because I had things sorted out. My first complex number goes on top. My second one goes down the side, and then we multiply into the box. So this box is 4 times 3. That's a real number because it's just 12. There's no I. The next one is I times 4. Because it has an I, that's a complex number. It's 4i. Here, 3 times -2 is -6. Don't forget to bring over the I. And the last one, I'm multiplying -2 times I, -2i times 2i. So I have, technically it has i's. It's -2i squared. But the I squared makes it change the sign and it goes away. So it becomes +2. So from here to here, we get rid of the I squared and we make the number positive just because I squared is equal to -1. And then we line them up, or we combine like terms. 12 with 2 is 14. For my complex, -6 and 4 is -2i. So there's my answer.